So we learned 2 ways to factor yesterday. Anyone remember what they are? GCF, which we'll use on the first warm-up, and bottoms up, which we'll use on the second warm-up. Good. How do I do GCF? Yeah, take out the greatest common factor. So in the first warm-up, what's the greatest common factor? 2x. So what would I have left in my first term? X and then 2. Good. All right, the second one's going to take a little longer. That's where we have a multiply number and an add number. What's my multiply number? 30. Good. And you get it from the first times the last. What's my add number? 17. Do you guys know 2 numbers that multiply to 30 add to 17? 15 and 2. All right, 15 and 2. Now what? Yeah, you're going to write 2 binomials. Yeah, and divide them each by the lead coefficient. In this case, it's a 3. If it simplifies, like the first one, simplify it. What do you do if it doesn't simplify? Yeah, you move the bottom number up. And then it's very important to check your work here. You can even just do it in your head. You could think x times 3x is 3x squared. Then you get a plus 2x. Then you get a plus 15x. That would give you 17x. And then you get plus 10. Good. What are your questions on our warm-up? All right, today we're doing section 5.2, day 2. Same title and goals as yesterday. We're just finishing up what we talked about. I told you there's 4 ways to factor. We learned 2 of them yesterday, so we'll learn the other 2 today. All right, you should already have this chart somewhere in your notes, so you don't need to write it down again. We learned these 2 yesterday. We're going to do these 2 today. Any questions? All right. Factor by grouping. Now, it's really up to you if you want to write this down. Kind of like what I said yesterday. Some people, the examples mean more than the step-by-step work. So it's really up to you. But when would you factor by grouping? You factor by grouping when you have more than 3 terms. Factor by grouping does not work with 3 terms. Doesn't work with 2 terms. So 4 or more terms you want to try grouping. How do you do it? You group the terms so that you can pull out a greatest common factor. And why do we do it? We group so that we can create binomials using the GCFs. So you're going to break it up basically into 2 parts, pull out 2 GCFs. Those go together. And then the numbers that are left over go together to make 2 binomials. Any questions on kind of the broad idea? Like I said, it'll make more sense when you see some examples on this. All right, so just to recap in case you missed it. We grouped these 2 and 2, and then we pulled the GCF out of each of them. So the first 2 terms, the GCF was 3m, so I pulled that out front. It left me with x minus 2. And then the whole goal is to get the same leftovers back here. So we pulled out a 4x, and we got an x minus 2. Here is where all the magic happens. The GCFs come together. They give you a binomial. The leftovers give you the other binomial. Now, since the leftovers are the same, you only have to write it once. If they're not the same, this does not work. Okay? What you have left in parentheses must be the same, and you only have to write it once. That's the answer. Yep. These are really good to check because it's kind of strange, a little different than what we're used to. So if we did 3m times x, we would get our first term. 3m times negative 2 would give us our second term. 4x times x gives us our third term. And 4x times negative 2 gives us the negative 8x. So this definitely checks out. We're good to go. What are your questions?
That x minus 2, if we don't have it twice, then what the answer would be?
Good question. He said, what if these don't match? Then this doesn't work. This only works if these match. Okay? So maybe it can't be factorable, or maybe you should try grouping it in a different way. Questions? All right, here's our second example. Oops. All right, I'm going to group them. 2 and 2. What's the GCF in the first two terms? 2a, good. That's 3 plus r. What do you guys want to pull out in the back? 7, and it's positive, right? So plus 7. That also gives us 3 plus r. So as I'm writing my binomials, what would they be? Good. 3 plus r. Great. And again, you can check your work here. 2a times 3 gives us 6a. 2a times r gives us 2ar. 3 times 7 gives us 21. 7 times r gives us 7r. Alright, so I'm going to group these first two, last two. Remember, that negative is with the 7 right now, so make sure it's in the parentheses with the 7. What's the GCF of the first two terms? 6w. So that leaves us x minus 3. What's the GCF in the second one? Yeah, if you pulled out a 7, would you have the right signs to match up with the x minus 3? No. So what do you actually need to pull out? A negative 7. Good. So double check your signs as you're going. That would give us positive x and negative 3, which is what we want. So I would have 6w minus 7 and x minus 3. Other questions? All right, I think that's enough grouping examples. Let's get to the next type of factoring. The next one is dots, is what I call it. It stands for difference of two squares. So basically what it's saying is if you have two squares, squares are like 4, 9, 16, 25, perfect squares, and a minus sign in the middle, these are super easy to factor. You take the square root of the first term, that goes in the front of your parentheses. The square root of the last term, that goes in the back of your parentheses, and then one gets a plus, one gets a minus. These are the easiest to factor by far. They barely take any time at all. All you have to do is remember when to spot them. The main thing is to check all those things are true. It's a difference. There's two of them, and they're both squares. So if it was a plus sign in there, it wouldn't be a difference. You couldn't use this. Any questions? All right, here's an example. So x squared minus 16. It's a difference. I have a minus sign. There's two of them, and they're both perfect squares. What times itself gives you x? What times itself gives you x squared? X, I totally gave it away. What times itself gives you 16? One gets a plus, one gets a minus. Pretty simple. If you double check this, x times x is x squared. Then you have minus 4x plus 4x. Those cancel out. And then 4 times negative 4 gives you the negative 16. Any questions on these? All right, here's our next one. All right, so what would go on the front? 3x squared and 3x squared. Good. What goes in the back? 1 and 1. One gets a plus sign, one gets a minus sign. We're done. Yes, like I said, these are a piece of cake. Questions? We can skip that one. It's pretty easy. We'll do this one just for fun. What goes in the front?
12.
Whoops, hold on. 12 and 12, good. What about the back?
5w squared.
5w squared and 5w squared, good. One gets a plus, one gets a minus, and put them in parentheses. Any questions? All right, take a second and look at this one. How would you want to start this? Very good. A lot of people see a trinomial and they instantly want to do the m and the a. If they have something in common, you can't do MA yet. Okay, you have to do the greatest common factor first. What's the greatest common factor here? 6. Great. All right, now we can do M and A. What's M?
18. Negative 18.
Negative 18. What's A? 7. Great. Anyone know them? Yes?
Negative 9, positive 2, or positive 9, negative 2.
Yeah, 9 and negative 2. So I still have the 6 out front. Then I'll have x plus 9. And I'll have x minus 2. What do I need to divide those each by? 6. Good. And not because of this 6, because of this 6. Okay, it's the one that's with the x squared. It's actually your a term. All right, now these are both going to simplify. And then I can move the bottoms up. Now, as you're checking this, I would just go kind of backwards. So 2x plus 3x is going to give us the 6x squared. Then I'd have the minus 2x plus 9x, which would give me the 7x. And then I'd have the minus 3. Then you can double check the distributing the 6 would take you back to the original, and it does. So now that you're getting the hang of factoring, let's remind ourselves why we learned factoring in the first place. How would I solve something like this? Yeah, it's the difference of two squares. So what would my factors be? 9n minus 4 and 9n plus 4. Good. Equals 0. Set them each equal to 0. And then what? Solve. Good. So I'm going to, add 4 and add 4. So 9n equals 4. Divide by 9. Divide by 9. N equals 4 over 9. And then we should get the same thing, but opposite signs. What are your questions on this? Now, I want to show you something cool that students often don't realize. Do you know how to solve this in another way? What if we added 16 to both sides? And then we divide by 81. And then we take the square root. And remember, anytime you take the square root, you have to put a plus and minus. The square root of 16 is 4. The square root of 81 is 9. So look, two methods to solve the same problem, and we get the same answer.
So just put plus or minus.
Awesome. Yep, if you want to put plus or minus 4/9, that is completely fine. Now, this method Does not work if there was an n term in the middle. So if it's a difference of two squares, you can actually solve it either way. You can do square roots and what you know about those, or you can factor it. It's really up to you. Both of them work. Both of them give you the same answer, so I'm fine with those. It does not work, though, on bottoms-up type problems if you had an n squared and an n term. We'll learn other methods for solving it, but factoring is the easiest. Any questions? All right, here's another one you'll need to know how to solve. What's special about this one? Yeah, there's something on the wrong side. How do I get it on the right side? Yeah, I need to have these equal to 0 or it does not work. So x squared plus 9x plus 20 equals 0. Then what? Good. My m is 20. My a is 9. Anyone know what they are? Good. What do I go back and divide by? Nothing, because my lead coefficient is 1. So I'm actually ready to set up the binomials equal to 0. So we get negative 4. And we get negative 5. Any questions on this? All right, let's just look at one that's just a little more challenging. And then I'll let you guys work on that homework from last night a little more. So I told you guys it's always easiest if you can keep which term positive? The first one, the one with the squared. So what do you want to do first? Yeah, let's get the 4p squared over with the 5p squared so that it stays positive. At the same time, you can also move the 24 if you'd like. So we have p squared minus 49 equals 0. Then what? Yeah, that's just a difference of 2 squares. So I'd have p minus 7 and p plus 7. So what would my answers be? Yeah, positive 7 and negative 7. You could write it like this if you want. Or you can actually go through and solve them, but this one's pretty simple. What questions do you guys have on solving by factoring? All right, here's your homework assignment. I told you guys this was over the course of 2 days, so it's the exact same problems as last night. You should know how to do them all now. So go back if you had to skip a couple, see if you learned anything today that would help you out, and then we'll go over questions at the beginning of class tomorrow.